Hey, geometry. I apologize. I am unwell today. Probably hear it in my voice, but I'm on antibiotics and I'm sure I'll be on my way to getting better soon. Hopefully, last night you watched the Ed puzzle on the surface area and volume of spheres. If you haven't, you need to go back and watch it. Okay? Why don't you take a minute and work on your warm up? You need to find the surface area of these two figures and the volume of these two figures. Please pause the video and give yourself a little bit of time to try these on your own. Okay, so a couple things you should know about spheres. So for your test, your SOL, and your final, you will have a formula sheet that goes through all the surface area and volume formulas. Okay, it also gives you formulas, stuff like Pythagorean theorem and all of the area formulas for basic shapes. I'll leave a couple blue ones here for you to look at. You can also just Google Geometry Virginia SOL formula sheet, right? And it'll show it to you. So you'll notice it has the formulas for a sphere available on your formula sheet, but it doesn't have the formulas for a hemisphere. Okay, so you need to remember the relationships between a sphere and a hemisphere. Important thing to note is that this portion, which is like the coin you would spin to create a sphere, is called the great circle. And however, whatever its surface area is, let's say it's worth 1 surface area, okay? The middle circle is worth 1. The top part of the dome, the relationship to that is then worth 2. So it's 2 times, the top part of the dome is worth 2 times the amount of the great circle. The bottom part of the dome is worth 2 times as much as the surface area of the great circle, which is where you get the formula of 4 pi r squared, okay? In a hemisphere, right, because you have a top dome that's worth 2, you don't have the bottom dome, but what you do have is a great circle, and the great circle we said is worth 1, okay? So altogether, you have 3 times as much as a normal area of that great circle, which is where you get these 3 for the hemisphere. Okay. A similar relationship exists between sphere and hemisphere for volume, but since we're not worried about surfaces, it's literally just half. Okay? So your answer should be as follows. If you need to pause it so that you can check all of your work or discuss it with a neighbor, please feel free. All right, so last class we talked about volume. Today we're going to talk about surface area of all of the prisms. It's going to be so exciting, okay? So, rectangular prism, probably the most commonly used surface area formula. It's what you normally think of when you're thinking of a prism. It's shaped like a box, right? And we have the formula of 2 times length times width, plus 2 times length times height, plus 2 times width times height. And where that comes from, the way we derive that, is length times width, if I were to unfold this box, would give us this pink square. That's length times width, the area of that pink square. And since that's the bottom, there would also be a top. So it's 2 times length times width, bottom and top. Height times length is the front and back of the box. Since there's 2 congruent shapes here to create a front and a back, you have 2 of them. Same with left and right. So you have 6 sides, or 3 pairs, 2, 4, 6 of them, okay? Very straightforward. However, when you're doing this type of problem, in order that you don't get confused with your variables, I would recommend writing them out to the side first. For a rectangular prism, it doesn't really matter which you assign to what. However, remember that length is typically left to right, width is typically front to back, and height should be between the 2 bases. Okay, height is equal to 9 here, okay? Once you've identified that, then you can go ahead and substitute it into your formula. I would do this directly into Desmos. and you should get 542 feet. All right, let's take a look at another one. Why don't we look at how we would set this one up? If the surface area of the cereal box below is 272 inches square, find the length of the box. Okay, very similar problem, but in this case we're starting out with the surface area of 272. And we're going to fill in the variables that we have and leave the ones that we don't. Okay, so we have 2 times length times width, 2 plus 2 times length times height, plus 2 times width times height. Okay, so the variables that we have available to us are width of 2. So anywhere where we have our width of 2, we'll substitute in a 2. This would end up being 2. And we have a 2 here as well for that width. And we've also been given our height of 12. So anywhere where we have a height variable, we can put in a 12. And then we can bring down any portion of the formula that we don't have, or that we don't have, or that we have already. Like the 2, length is unknown, plus 2 times length is unknown times height, plus 2 times 12. Okay. Once you solve out that, you should end up with a multi-step equation. You end up having a constant and 2 variable expressions, which you can combine and solve out for length is equal to 8. Pretty straightforward. So because rectangular prisms are used so often, they have their own particular formula. All other prisms, for any other prism that has a non-rectangular base, we use the formula of surface area is equal to height, remember height is between the 2 bases, times perimeter, and that is the perimeter of the base, plus 2 times the area of the base. Remember that the area of the base calculation is going to be determined by the shape of your base. Okay, a prism is defined as any solid where your 2 bases are congruent and parallel to each other. Okay, most of the time it's demonstrated as a triangular prism, and on your formula sheet they show it as a triangular prism. But as we'll see, you can use this with other shapes as well. All right, so what we're really doing here is finding the surface area for the lateral area and then adding the area of the bases. Lateral area, if you have not heard that term before, is the entire area, refers to all area with the exclusion of the bases. It's this pink portion. And lateral area is usually a formula that's provided to you too. It's this height times perimeter, right? The reason why it's height times perimeter should make sense to you because the height is the distance between the 2 bases, which would be from here to here, and then the perimeter of the base is all 3 of these sides. If I were to kind of unfold these sides, you'll notice it matches up to the length of this entire rectangle. So if I multiply the perimeter of the triangle times the height, it gives me the total area of this purple or pinkish rectangular figure portion that is our lateral area. Okay? The other portion that we haven't accounted for would then be the area of the bases, our 2 congruent parallel surfaces. Okay, and we find the area of one of them, multiply it by 2, add it to the lateral area. Pretty straightforward. All right, so let's check out a little bit of what that might look like. Again, this is going to be one where you want to identify each of the variables that you need before you start your calculation, right? I'm going to need, my surface area formula includes height, it includes perimeter of the base, and I'm going to need area of the base. Okay, for height, please remember, okay, height is the distance between the 2 bases. Our bases are the triangles here. It's a triangular prism. The distance between the 2 is going to be 16. Now, if this was oriented differently, such as on its flat side, on a rectangular prism side, it would still be 16. Perimeter If you guys recall your perimeter calculations, perimeter should be equal to all sides of the lengths of the base added together. So we have 9, 12, and then 15, which you'll have to look down here for. Now be careful, you'll notice that this is a right triangle, so they could have easily left one of these unknown and you would have had to use Pythagorean theorem to solve for it. That is very frequent. You'll also notice this is a 3, 4, 5 right triangle. Okay, so our perimeter is 9 plus 12 plus 15. Okay, and then our area of the base. Remember that our area of the base formula is going to be entirely dependent on the shape of our base. And I'm only calculating the area of this triangle right now. Since it's a triangle, we use the area of a triangle formula. 1/2 the base of the triangle times the height of the triangle, not the base of the prism. Just talking about the triangle here. So that's 1/2 our base of 9 times our height of 12. In a right triangle, the base and height are your legs. In other triangles, remember that the base and the height are at 90 degrees to each other. Okay? So now that I have all of this information, we can easily just plug this into our formula to solve. Okay, we have surface area of plus our area of the bases, and you'll notice it's 2 times 54, or our area of the base. Here's our height, and here's our perimeter. It should work out to 684 meters squared. All right, let's run through one that has a different base formulation. Okay, so you should recognize this as a trapezoid. Okay, so this is a trapezoidal prism. Okay, we know it's still a prism because it has 2 trapezoids that are congruent and parallel to each other. We're going to use the same formula of height times perimeter plus 2 times the area of the bases. So I need all of those variables before I plug it into Desmos or my calculator. Okay, so height, perimeter, and then area of the base. Okay, height, guys, should always be the distance between the 2 bases. It's our 2 bases are the trapezoids here. Our height is 9. Don't be fooled. Do not select 12.4. It's the distance between the 2 trapezoids. How far apart are those bases? Okay, perimeter. Looks like we've got an isosceles trapezoid here. So this side and this side are congruent, and it's marked here as 13. So we have 13 plus 13, or 2 times 13 if you'd like, plus our bottom base of the trapezoid, which is 10, and our top base of the trapezoid, which is 18. The formula for the area of a trapezoid, if you're not overly familiar with it, that's okay. It is on your formula sheet. It is 1/2 base 1 plus base 2 times height. Okay, so 1/2 base 1 and base 2. Bases of a trapezoid are the 2 sides that are parallel to each other. So we have a 10 and an 18 for our bases. Okay, 10 plus 18. And then that's going to be times our height, which is given to us as 12.4. Okay, so that's our setup. Once we have all of that information, we just plug and chug that into our surface area formula. Okay, our base ends up being equal to 173.6. So we have 9 times 54 times 2 times our area of our base, giving us 833.2 millimeters square. Okay, your turn to give this a shot. Let's take a look at how you're going to do this. Sorry about that bell. I don't remember if this one requires you to do a Pythagorean theorem calculation, but be on the lookout. Feel free to pause it as you're waiting. Okay, so Pythagorean theorem was not necessary to find any missing dimensions in this case. However, it could have easily been where you needed to find a measurement. You would always try to find it using Pythagorean theorem, setting up a right triangle. For our rectangular, our triangular prism, you have a height of 3, a perimeter of 27, and your base should have been 1/2 12 times 4.1 or 24.6, giving you an answer of 130.2 kilometers square. For your trapezoidal prism, you had a height of 15, distance between your two bases, perimeter of 73, and a base, area of the base, of 246. Make sure you're using the area of a trapezoid formula for that. Your answer should have been 1,587 feet squared. I'm going to continue this video in a different link to ensure that this one isn't too lengthy to load. So please take this moment to switch over to video part 2.